Hello students, I am R. Mukherjee. Today we are going to study a lesson of geography, that is cartography and the study of maps. Cartography means the art or science of map making, and the person who makes map is called cartographer. Students, we will study about cartography in the last segment of this lesson. But in the first segment, we are going to study the basic language to study map, which includes direction, scale, symbol. And in the second segment, we will study about kinds of map, for example, political map, physical map, thematic map, etc. And then in the last segment, we will study about the history of map making, that is cartography. So let us start the first topic, and that is direction. As you know that we have four cardinal directions: north, east, south, west. These cardinal directions are also called cardinal points. They are denoted by their initials N, E, S, W. The direction between the four cardinal points are called intermediate or intercardinal directions: northeast, southeast, southwest, northwest. And the intermediate direction between the intercardinal and cardinal direction is called secondary cardinal directions. Let us understand it. Now we have these four cardinal points or cardinal directions: north, east, south, west. We have, and in between these 4 points, we have 4 intercardinal directions. They are northeast, southeast, southwest, and northwest. And between these cardinal and intercardinal direction, there is a direction called secondary intercardinal direction. And there are 8 secondary intercardinal directions: 1, 2, 3, 4, 5, 6, 7, 8. So they are called north, northeast, east, northeast. Now it is north, northeast because it is in the north of northeast. This is northeast, and this direction is in the north of northeast, so it is called north, northeast. East, northeast because it is in the east of northeast, and it is called east, southeast because this is southeast, and this direction is in the east of southeast, so it is called east, southeast. South, southeast, now it is in the south of southeast. Then we have south, southwest. This is southwest, and this direction is in the south of southwest, so it is called south, southwest. West, southwest because this is southwest, and this direction is in the west of southwest, so it is called west, southwest. Then we have west, northwest. Now this is northwest, and this direction is in the west of northwest, so it is called west, northwest. Now we have N and W. N and W, that means north, northwest. So here is northwest, and this direction is in the north of northwest, so it is called north, northwest. Students, any direction can also be explained by using a correct angle, because we use compass to find a direction. As you know that we use compass, nowadays magnetic needle, to find a direction, and a compass has 360 degrees, So to know the correct direction of a place, we assume that north is a 0 degree, and then calculate the angle of that place. All angles are calculated, all angles are measured in a clockwise direction, beginning from north. So suppose place A is here, place B is here, and place C is here. So we can say that place A is at 25 degree, and then we can say that place B is 195 degree, at 195 degree, and we can also say that place C is at 335 degree. So children, now the question is, how do we actually find a direction? How do we find a direction to a new place? That is a very important question. Now, as you know that we use sunrise, sunset, pole star, which is called Dhrutara, and magnetic compass, magnetic needle, to help us find directions. And a magnetic needle and a magnetic compass is very helpful to find directions. People have been using, navigating with magnetic compass for several centuries. And most of the compasses, are marked with cardinal and intercardinal directions. Now the question is, how does a magnetic compass work? Now I am going to focus today on the magnetic compass and how it functions, how does it function, how does it work, what does it mean, what does a magnetic field mean. These are the main points I am going to explain today. Now, the question is that how does a magnetic compass work? And what about the compasses people use in ships and airplanes? Are they same or different? Now, we will discuss it later, but today let me first focus on the magnetic compass. How does it work? Now, as you know that the magnetic compass points to the north. Magnetic compass points to the north because it aligns itself with the magnetic field produced inside the earth. In other words, the rate pointer in a compass is a magnet. You see the needle in a compass is a magnet itself, and it's being attracted by the Earth's own magnetic field, which is also called geomagnetic field, and always points to towards the north. So that is called magnetic north pole. Here is magnetic north pole. You see, this is called magnetic north pole, and the needle always points towards the north, and this is called magnetic north pole. But there is another north. There is another north, that is geographic north. This is another north. This is geographic north, or it is also called true north, and it is used to draw maps. It is always at right angle, 90-degree north latitude. Okay? But the magnetic needle always points to the north, which is called magnetic north pole. So the magnetic needle doesn't point to the geographic north. It is always points to the magnetic north because it is being attracted by the Earth's magnetic field. You must understand it. And the opposite of magnetic north pole is the magnetic south pole. You can see here. And the opposite of geographic north is geographic south. This is geographic south pole and this is geographic north pole. Okay? But although a compass always points to the north, but it does not point to the geographic north pole, which is located at 90-degree north latitude. Instead, it points to Earth's magnetic north pole, which is located at 80-degree north latitude. The Earth's magnetic south pole is also located several degrees of latitude away from the geographic south pole. Okay. So a compass pointer is a magnet. You must understand. The compass pointer, suppose this is a compass pointer, and the compass pointer is itself is a magnet and has north and south poles, and its north pole points to the Earth's magnetic north pole. You listen very carefully what I say. I said that compass pointer means needle, is a magnet and has north and south poles. And its north pole always points to Earth's magnetic north pole. Why does this happen? This is the question. Please listen this point very, very carefully, because it is very interesting. You see, the question, I repeat, why does the magnetic needle's north pole points to Earth's magnetic north pole? Why I ask this question? Do you understand? Because magnetism is one of the first bits of science we learn in school. And just about the first thing we discover is that like poles repel and unlike poles attract. What does it mean? Like poles means similar poles, repel means push away, and unlike poles attract means pull towards one another. So if there is like poles, then there will be repulsion, and if there is unlike opposite poles, there will be attraction. This is the basic principle. So you see, if you hold two bar magnets, so their north poles are almost touching, they will push away from one another. North pole and north pole there will be repulsion. And if you turn one of the magnets around, so the one magnet's north pole is near to the other magnet's south pole, the magnets will pull towards one another. There will be attraction. So the question, I repeat, why does magnetic needle's north pole? Suppose this is magnetic needle and this is the north pole. So magnetic needles, why does magnetic needle's north pole attract to the Earth's magnetic north pole? Why does it happen? This is a very important question. The answer is very simple. Earth's magnetic north pole is actually the magnetic north pole is actually the south pole of the magnet inside the Earth. The magnetic field inside the Earth has south and north pole, but actually which we call north pole is actually the south pole of the magnet Earth. Okay? So the magnetic needle's north pole actually points to the south pole of the magnet Earth. But it is called magnetic north pole. Why? Because just to avoid the confusion, that is the point. Actually, the needle's north pole points to the south pole of the magnet Earth, the magnet inside the Earth. But it is called magnetic north pole to just avoid the confusion, because it is close to the geographic north pole. So it would be confusing to call it magnetic south pole. So just to avoid that confusion, we call it magnetic north pole. Now imagine a huge bar magnet passing through the Earth's axis. The south pole of the magnet is actually in the north of the Earth, and the north pole is actually in the south of the Earth. You got the point? But can you imagine, now I'm going to tell you a very interesting topic, very interesting point about this magnet Earth and the magnetic field and its south pole and north pole. Now, can you imagine reversing the magnet bar of the Earth? क्या आप कल्पना कर सकते हैं कि ये जो मैग्नेट अर्थ का ये जो मैग्नेटिक पोल्स हैं, साउथ पोल एंड अर्थ नॉर्थ पोल, ये रिवर्स हो जाए? कैन इट हैपन? If I say that it can not only happen, but it actually happened hundreds of times over the last 300 million years. And I will show you a picture. Okay. Now look at this. Now today it is a magnetic field, and the south pole is actually in the north of the earth, and north is actually in the south. North pole of the magnet earth is in the south. But it actually reverse, and it happened in hundreds of times in the past. The scientists have found it out. And when it happens, it just flip the magnetic pole. North pole will be on the south, north, and south pole will be in the south. So you see, ये मैं कोई कहानी नहीं सुना रहा हूँ, ये एक्चुअली वास्तविकता है. The earth magnetic poles have changed, their places hundreds of times, and each time reversing the earth's magnetic field. So you can learn more about it, with the help of Google. You can learn about it. And now I'm going to tell you another very interesting point about this magnetic field. Another very interesting feature of the magnetic field is that the magnetic field, the north magnetic pole, which is actually the south pole of the magnet earth, is actually shifting towards Russia. This is another very interesting point. Now you can see here that magnetic north pole was at 70° northern latitude in 1900 AD. Now it shifted to 80° northern latitude in 2000 AD. And then today, 2020, it is here. And it is actually moving towards Russia. Now I will show you the world map so that you understand it better. Actually this north pole, magnetic north pole, was here. Now it is moving like this, and now today it is here almost, and then it is going towards the Russia, Siberia, yeah. So this is a very interesting point. Now scientists are actually working on it, why it is happening. But this is a fact and you must understand it. So students, now the question is, let us understand what is actually magnetic field. What is magnetic field? What does it mean? Now magnetic field is a huge region actually. Now magnetic field is a huge region that extends outward from the earth, earth of several thousand kilometers, but is strongest at the poles. You can see the extent of magnetic field, which is also called magnetosphere. This magnetic field extends out in the space, into the space. So it extends from the interior of the earth out into the space, where it actually meets the solar flares, solar wind. And what is solar flare, solar wind? A stream of charged particles emanating from the outermost part of sun's atmosphere, which is called corona. The temperature of the corona causes its charged particles to move at a very high speed, and the speed is so high that the charged particles can escape the sun's gravity. The solar wind ejected by the corona collide with the magnetic field of the earth, and you see the magnetic field of our planet earth extends about 6,500 kilometers above the surface of the Earth. So it covers protect the ozone layer also. The Earth's magnetic field serves to deflect most of the solar wind, whose charged particles would otherwise strip away the ozone layer that protects the Earth from a harmful ultraviolet rays. Students, यहाँ पर ये समझना ज़रूरी है कि धरती के पास हमारे पास एक ह्यूज मैग्नेटिक फील्ड है. ये मैग्नेटिक फील्ड जिसको हम जियो मैग्नेटिक फील्ड कहते हैं और ये या मैग्नेटोस्फीयर भी कहते हैं, और ये मैग्नेटिक फील्ड अर्थ के इंटीरियर पार्ट से जन्म लेती है, पृथ्वी के अंदर से जन्म लेती है और आउटर स्पेस तक फैलती है. ये कुछ ऐसा दिखता है जैसा यहाँ दिखाई पड़ रहा है, बट हम इसे खुले आँखों से नहीं देख सकते. और ये सोलर विंड जो कि सूरज की तरफ से जो सोलर विंड आता है जिसमें चार्ज पार्टिकल्स होते हैं, इससे कोलाइड करता है और वो डिफ्लेक्ट करता है चार्ज पार्टिकल्स को नॉर्थ पोल और साउथ पोल की तरफ, क्योंकि यहाँ ये मैग्नेटिक फील्ड सबसे स्ट्रॉन्गेस्ट है. और इस तरह हमें सोलर फ्लेयर्स के जो बैड इफ़ेक्ट हैं, जो उसके अल्ट्रावायलेट रेज हैं, तमाम उन चीज़ों से हमें बचाती हैं. और ये मैग्नेटिक फील्ड सबसे ज़्यादा इंटेंस होता है नॉर्थ पोल एंड साउथ पोल में, ये ध्यान रखना है. धरती पर जो जीवन है वो एक तरह से कहें तो मैग्नेटिक फील्ड के कारण भी बचा हुआ है. ऑफ कोर्स एटमॉस्फेयर हमें प्रोटेक्ट करता है, बट मैग्नेटिक फील्ड भी एक बहुत बड़ा कारण है उसका. इसका एक इम्पॉर्टेंट रोल है और यह धरती के आसपास एक कवर जैसा बनाता है. सो आई होप दैट यू अंडरस्टैंड इट. नाउ लेट अस अंडरस्टैंड what is actually magnetic field. Now we will understand what the magnetic field, how magnetic field emerge or occurred. This is very important point. So for that we will have to study the structure of the structure of the earth. Structure of the earth. First let us understand this. There was a scientist called William Gilbert, and he explained this magnetic field some I think 400 years ago, that is in 16th century, that earth behaves like a huge bar magnet, one pole up in the Arctic and another pole down in Antarctica. However, it had to wait until the development of technologies such as seismographs, which detect and measure earthquake waves. Now, scientists discovered that this is the crust, and then there is a oceanic crust and continental crust, and we actually live on this crust, as you know. And then there is lithosphere, and below that there is a mantle, and mantle has two parts, upper mantle and lower mantle. This is, you can say, upper mantle, lower mantle, and this is upper mantle. I hope that you can see it. Okay. So now there is outer core and inner core. So this is the inner part of the earth. But it is also divided into two parts, the outer core and this is the inner core, the yellow part. You can see this is the inner core. But the inner core is primarily solid ball of radius of about 1220 kilometers, which is about 70% of the moon's radius. Just imagine. The size of this inner core, which is actually solid ball, which is the radius of this inner core is 1220 kilometers, which is about the 70% of moon's radius. but the temperature of inner core is more than the outer core. That is, the temperature here is around 5200 Celsius, which is very almost similar to the sun's temperature. So this part has the highest temperature, but surprisingly the inner core is solid, whereas the outer core is liquid. The outer core consists of liquid metals, mainly iron and nickel, and everything in the outer core is in liquid melted form, molten form, okay? But surprisingly the innermost core, which is called inner core, is solid ball. It is solid. Now the question is, why is the inner core solid even though it is hotter than the outer core? This is a very important question. Now the inner core is indeed hotter than the outer core. However, the pressure on the inner core is greater than the pressure on the outer core. And because of the pressure effect overrides the temperature effect, the inner core solidified. Now the question is why the Earth has magnetic field. But before that, let me explain it again in Hindi. The planet Earth का जो actually structure है, इसमें below the mantle, ये जो mantle है उसके नीचे जो आप देख रहे हैं ये कोर है. ये आपके सामने धरती का जो स्ट्रक्चर का जो चित्र है, इसमें यह दिखाई पड़ रहा है कि ये कोर है. इसको हम कोर कहते हैं. और आउटर कोर जो है वो लिक्विड फॉर्म में है और इनर कोर जो है वो सॉलिड फॉर्म में है. ना आउटर कोर में जो आयरन और निकल है और अन्य मिनरल्स हैं, वो सब लिक्विड फॉर्म में है. कहाँ? आउटर कोर में. इसे ध्यान दीजिए आप. जबकि इनर कोर सॉलिड है और यहाँ तापमान सबसे ज़्यादा है. इसलिए मैंने प्रश्न किया था कि वाई इज़ इनर कोर सॉलिड इवन दो इट इज़ हॉटर दैन आउटर कोर. ये कैसे हुआ कि इनर कोर में टेम्परेचर ज़्यादा है और फिर भी वो सॉलिड है, जबकि आउटर कोर में सब कुछ पिघला हुआ है, सब कुछ मॉल्टन फॉर्म में है, लिक्विड है. सो यहाँ उत्तर ये है कि धरती का जो प्रेशर है वो इनर कोर पे सबसे ज़्यादा पड़ता है और आउटर कोर पर उतना प्रेशर नहीं होता. और जो प्रेशर है वह टेम्परेचर को ओवरराइड करता है. यानी कि वहाँ टेम्परेचर का इफ़ेक्ट को ओवरराइड करता है प्रेशर जो फैक्टर है, और इसके वजह से ये सॉलिड बनता है. सो मैग्नेटिक फील्ड के बनने के पीछे ये जो कोर है इसका एक वाइटल रोल है. मैग्नेटिक फील्ड के बनने के पीछे जो मेन कारण है, हम जो बात कर रहे हैं वो एक्चुअली वी आर गोइंग टू अंडरस्टैंड about the magnetic field. Okay, so now the question is why the Earth has a magnetic field. The Earth is rotating. आपको मालूम है, you know that the Earth is rotating on its axis, and because of the movement of the Earth, the molten matter in the outer core also moves. यहाँ जो molten matter है, यहाँ जो liquid है, आयरन एंड निकल और मिनरल्स का जो लिक्विड फॉर्म है वो भी मूव करेगा. एंड बिकॉज ऑफ दिस देयर इज ह्यूज टर्बुलेंस क्रिएटेड इन द आउटर कोर विच जनरेट्स कॉन्वेक्शन करंट. यहाँ पर जो मूवमेंट होता है इसमें ये ठीक समझें कि जैसे एक अंडे को आप ले लें और उसे ज़ोर ज़ोर से घुमाएं तो उसके अंदर जो योक है वो भी घूमना शुरू हो जाएगा. ठीक ऐसा ही यहाँ कुछ होता है कि जब ये पृथ्वी घूमती है तो ये आउटर कोर में जो लिक्विड है ये भी होता है, घूमता है, और जिसकी वजह से यहाँ एक ज़बरदस्त टर्बुलेंस क्रिएट होता है. और इसके कारण यहाँ कॉन्वेक्शन करंट क्रिएट होता है विच releases charged particles and that generate magnetic field, और उसके कारण यहाँ एक magnetic field बनता है. So what we understood is that the flow of liquid iron and nickel in the outer core generate convection current, which in turn produces magnetic field, and this cycle continues because Earth is moving. So this process of self-sustaining loop is known as geodynamo. Okay. Now let us understand what are the benefits of this magnetic field. So क्या इसके benefits क्या हैं? So benefits मैंने आपको बताया कि ये पहला तो ये है कि ये हमें सन के जो फ्लेयर्स हैं उससे प्रोटेक्ट करता है मैग्नेटिक फील्ड. सन के जो फ्लेयर्स हैं, जो बैड इफेक्ट है जो उसके सोलर विंड के जो अल्ट्रावायलेट रेज हैं और जो चार्ज पार्टिकल्स हैं उससे हमें ये बचाता है. दिस इज़ द फर्स्ट थिंग, द बेनिफिट ऑफ दिस मैग्नेटिक फील्ड. The second benefit is that some animals use magnetic field to navigate or migrate. For example, birds like garden warbler use magnetic field to guide their annual migration. Migrating birds have structures in their eyes. उनकी आँखों में एक स्ट्रक्चर होता है जिसे मैग्नेटोरिसेप्शन कहते हैं, और ये जो है ये उनको that allows them to see Earth's magnetic field as a visual pattern, and this is very interesting. They use this magnetic field to move from one place to another place. The Earth's magnetic field is also used for navigation, as I told you. We use compass, and this is the very useful device, compass, we use to find direction. So these are three very important benefits of magnetic field. So, but the compass, as I told you, compass used in aircraft to align the aircraft with the center of the landing strip with the help of compass, but actually that compass is not the same which we use on the ground. That is called gyro compass. You can study about gyro compass in the Google. Okay. So thank you students. I hope that you understood. These are some interesting points. Now in the next video I will explain the scale and symbols. Okay. Thank you.